In this question, they're asking us to calculate the critical points of a function z, where z is a function of variables x and y, and z is defined to be x cubed plus 3x squared minus 9x plus y cubed minus 12y. So let's go ahead and calculate the critical points. To calculate the critical points of z, what we're going to do is we're going to take the partial derivatives of z. So the partial derivative of z with respect to x is 3x squared plus 6x minus 9. And the partial derivative of z with respect to y is equal to 3y squared minus 12. So in order to calculate the critical points, we want these partial derivatives to be equal to 0. So what we're going to do, I'm going to make equation 1. I'm going to set the partial derivative of z with respect to x. I'm going to set it equal to 0. So 3x squared plus 6x minus 9 is equal to 0. And the second equation that we have is that 3y squared minus 12 is equal to 0. So now we have to solve these two equations and two unknowns. So I can see from the first equation here, if I divide from equation 1, if I divide both sides of equation 1 by 3, I end up with x squared plus 2x minus 3 is equal to 0. And of course, if I solve each of these, or if I solve this equation, I can factor it, and what I get is x plus 3 x minus 1 is equal to 0. And of course, the only way to make this equation true is if either x plus 3 is equal to 0 or x minus 1 is equal to 0. If x plus 3 is equal to 0, that means that x is equal to negative 3. If x minus 1 is equal to 0, that means x is equal to 1. So we have two x values that make the first derivative, the first equation true. From equation 2, we have that 3y minus 12 equals 0. I can divide both sides of this equation by 3, and I end up with y squared minus 4 equals 0. And if I factor this, I end up with, well, actually I could just bring the 4 over to the other side and get y squared is equal to 4, which means that y is equal to plus or minus 2. So what are the critical points? Well, as long as x is equal to negative 3 or 1, we're guaranteed that the first equation is 0. If y is either positive or negative 2, we're guaranteed that the second equation is true. So any combination of these x and y values will be critical points. So the critical points of z are equal to, so the critical points of z are equal to negative 3 for x and say 2 for y. Could be negative 3 for x and negative 2 for y. We could also have 1 for x and 2 for y, or 1 for x and negative 2 for y. So these are the four critical points of z.